Hi, my name is Alex. I work at Google, and my team supports the toolchain for Fuchsia, among other Google projects. I'm going to talk about the multi-call driver. It's a build option that we added that links many LLVM tools into one binary. It's similar to BusyBox, and the binary we just call it LLVM. And tools like Clang will just be a symlink to it. We really prefer static linking for a lot of reasons. We don't want users coming to us saying they had a bug, we try to reproduce it, it turns out they were just using their own libraries, they mess with the RPath, whatever. We prefer static linking a lot, but the downside is a lot of tools have a lot of overlap in the libraries. Clang scandeps was one of the most egregious we found. On its own, it was about 100 megs. When we added to the binary, it was only 1. The reason we care is that we try to ship a new toolchain every week, and our toolchain was about 2 gigs at the time, and some users were complaining that it was too much. So before we rolled it out, we had a gig and a half in our bin directory, and now it's only 640 megs. This is an example of a tool that got converted. So if you ever see tool name _ main in lieu of just main, this is why. You also see in the CMake this generate driver argument. Using it is really simple. This is our cache file that we use to build our toolchain. You just set LLVM tool, LLVM driver build on, and we also add LLVM driver to our distribution. It turned out not to be quite that simple. On Windows, the create symlink CMake routine that we have just copies, so we ended up with n copies of an entire toolchain in Windows, so we disabled it on Windows for now. We don't have enough users that we haven't looked into changing that. Also, some people on our team were using this cache file for local development. If you're doing iterative development, you don't want to build the entire toolchain you don't want to relink the toolchain, the entire toolchain every time. So we also disable it when building locally. Rolling it out was also really simple. We only ran into 2 issues, and I maintain that was their fault, not ours. The first one was Clang is no longer a symlink to Clang version, it's just a symlink to LLVM. This is actually a happy accident. We don't like that that we were shipping the version because we ship every week. It's not meaningful for us. People would always say, oh, Clang 17 is broken. It's not meaningful. So they just changed it to presumably just use LLVM instead of Clang version, even though we said don't hard code. The second one is a little more complicated. When you compile with canonical prefixes, it tells Clang to look at the real path of itself. In this case, that was LLVM. And so the Clang driver, when it reinvokes itself with canonical prefixes, has to do full path LLVM, and then the first argument will be Clang. Someone else was also hard coding the expectation that that tool would be called Clang, and we told them not to do that. I'm sure they still hard coding, but yeah. Not all tools are part of the driver. There is an issue that CL opt is used pretty ubiquitously, and CL opts with the same name cannot be linked into the same tool. You can imagine almost every tool has -o for output. So first, what we've had to do for tools that we want to add is to switch over to using opt table. You can also do function scope CL ops, but generally when you're doing these transitions, you might as well go to the preferred opt table. And so there are still some few tools left. Most of these are the Clang tools. There's Clang tooling common options parser, and that expects the CL opt interface. Those tools weren't that large, so we didn't prioritize that work, but in aggregate, they would be pretty considerable. That's it. I did want to shout out Chris Bieneman. It was initially his patch, but he ran out of time. And so we ended up commandeering that patch. We really liked it. And Masquerade, Pihozik, and Andres, they did a lot of reviews and helped with the transitions.